So in order to prove the case, what we have done is we have locally set up an Apache server with the following configuration of timeout of 10 seconds and a max request of 3 as shown below. So this will be the configuration at the Apache server, and we can access that server using an IP called 192.168.0.60. So it brings out the default web page with the keep alive settings on, and the header will give us the keep alive information. Okay, so now in order to test the scenarios, we have actually created 3 cases. So the scenario number 1, request after every 10 seconds. After every timeout has occurred, we will make one request. So there is no significance for the max request count here. So each request, so the result is obvious. Each result request will require a new connection. So I don't think we would need a run of that case. So we will move on to the case number 2, where we will be firing 4 requests within 10-second timeout. Basically more than the max request count configured, with a delay of 100 milliseconds between the calls, so that all the 3 calls or 4 calls get over within the 10-second timeout. So let's see how does it happens. So this is a sample Java application that just hits the URL and just print out the header alone. The keep alive header alone will be printed out as a response. So the program parameters includes the URL and how many times it should be invoked. So we will be running with this setup. So I'm going to run with a 100 millisecond delay between calls. So the request will be made every 100 millisecond in a loop. So I'm going to run this case. So every 100 millisecond the call has been made. Let's see what happened. So the first request was made, and the response what we got is timeout 10 second and max 3. So this is the value comes as part of the response, and we sleep for another 100 milliseconds. Once the sleep is over, another request will be made. So let's see what happens for that keep alive response. So that response, if you clearly notice, that max has been reduced to 1, 2 from 3, and the next call again reduced max to 1. The timeout doesn't change, but the count reduces to 3. And the next call, the fourth call, it actually gave us again the max value of 3, and it continued to 1. Again it continued 3 to 1, like that. So what does that mean is, in the first request, when this request was made, a TCP connection was established between the program and the Apache server. The subsequent call that was made actually reused the connection what was already available, and it could keep reusing the connection up to the max request count configured. So that means in our case it is 3, so it could reuse the connection for 3 requests. So fourth request wanted to have a new TCP connection established. So again the header parameter reset back to 3. So that's the behavior we see here. So the result is, for the case 2, the first 3 requests will reuse the same connection. Every fourth request will require a new connection. So this is the same idea that we are going to use it in the case number 3 as well, which we will be using it for our dummy calls. So let's see what happens in the case number 3. So what will happen in case number 3 is 4 requests will be made, but not so frequently, with an interval of say 8 seconds, which will be less than the 100-second timeout. Okay, so let's go ahead and run and see the behavior. So I'll change the sleep time again to 10 milliseconds. I'll clear this. Let me run. So when it runs, the first request, as usual, came back with the timeout of 10 and max 3 as response value. And the next request again, max 2. This next request will be timeout again 10 and max 1. So the next request will be again, will reset back to time 10 and max 3. So, and this pattern continues. So here what has happened is the time between the calls was 8 seconds. And if you look at closely, it actually 8 into 3, 24 seconds. We were able to keep the connection alive even though the timeout was 10 seconds. So this is the behavior, exact behavior we are using by making a dummy calls. So the scenario, the result is the first 3 requests can reuse the same TCP connection. So basically the same TCP connection will be maintained up to say 24 seconds. So when we have a timeout of 180 seconds and 1000 requests, so we can actually maintain the same connection for a longer period of time, as we discussed. So the conclusion here is that if there is a real or a dummy call happening between the client and the server, we see it periodically before the timeout value occurs, then it is possible to extend the life of the TCP connection beyond the timeout value configured. So if there is a timeout second, as we have seen already, 180 seconds and requests as thousands, then it is possible to hold or reuse the same connection for a longer period. So the advantage that we will be getting is for every connection, you need not have to re-establish the entire handshake, and this will give a better response time at the client side. So hopefully this clarifies the use